Okay, so in this video, I will be going through these dot points relating to chemical reactions and chemical equations. Once again, I will create some timestamps so you can go straight to the dot point that you want a recap of. So the first one is describing the law of conservation of mass. Now this is very simple, and I'm sure a lot of you have heard of this in your junior years, but essentially the law of conservation of mass states that mass is conserved in a chemical reaction, which means that the total mass of the reactants would equal to the total mass of the product. So I have a little bit of an example here. I don't know whether you have seen this before, but when you add baking soda and vinegar together, and maybe don't do this at home, but when you add these two together, there will be a chemical reaction occurring. Some carbon dioxide gas is going to be released, and you can see a lot of bubbles. So let's say if you put the baking soda and the vinegar in a bottle and then you seal, you can put the lid on or you can seal it with a balloon. Essentially what happened is the total mass of the product. So once the reaction is completed, what you have in the bottle is no longer baking soda and vinegar. You're going to have an ionic compound, and then there's some gas released in the form of carbon dioxide. But all the products that you're going to get, the mass of all of these should equal to the mass of the baking soda and vinegar that you put in the first place. So that is the law of conservation of mass. The next dot point is to describe what happens in a chemical reactions in terms of chemical bonds. So I'm just having a description of what that means here. A chemical reaction involves a rearrangement of atoms. That is one way to define a chemical reaction. And there are two things that happens when it comes to chemical bonds. The first thing is some chemical bonds in the reactants must be broken, and then new chemical bonds are then formed to create products. So I'm just going to show you an example. Let's say I have hydrogen plus oxygen going to H2O. I always use this example mainly because it's quite fast to draw. So if you look at the equation, you can see that this starts with some hydrogen molecules. So let's say this is a drawing of two hydrogen atoms being linked together. So this is the chemical bond. And then there is another molecule of hydrogen containing once again two hydrogen atoms linking together. So you have two chemical bonds here, and I'm just gonna try to make the second one a little bit more similar to the first one. So this is these are two examples of the reactants, and then you're going to have one molecule of oxygen also linked together by chemical bonds. And I'm just trying to be very accurate here. You don't need to know that it's a double bond. Now, in order for the products, which is H2O, to be formed, what actually needs to happen is the bonds in the reactant must be broken, because you need to be able to create new bonds between oxygen and hydrogen, because that's what holds the products together. So I basically need to break this bond, I need to break this bond, and I need to break this bond. So the bonds in the reactants must be broken, and once the bond in the reactants are broken, essentially what you have, you end up with like 4 hydrogen atoms, and then you have 2 oxygen atoms, and these can then rearrange to form new bonds. If they don't form new bond, then essentially you cannot say that a chemical reaction has taken place. So the new bonds are formed here, so you're going to have new bonds being formed between oxygen and hydrogen this time, and then another bond between oxygen and hydrogen. Okay, so that is essentially what happens in a chemical reaction. You break the bonds in the reactants, you have the atoms, and then they reform new bonds to make something else. That's called the products. All right, the next 3 dot points is about interpretation of chemical equations and looking at identifying reactants and products in a chemical equation. So I think this is probably very straightforward. If you look at a chemical equation, anything on the left hand side of the arrow, so you need to know where the arrow is. This is the arrow. Anything on the left hand side of the arrows will be the reactants. So what you start off with, and anything on the right hand side of the arrow. So the arrow is always pointing towards the product. So this, in this case, is the product, which is what you end up with. So that's identification of reactants and products. The second thing is, actually I think I can talk about the second dot point here as well, is determine the types and number of atoms in a given compound. So in here, So we did this before when we look at the ionic compounds. You can watch that video if you want more examples. But essentially, the subscript tells you how many atoms are in one molecule, and then the coefficient tells you how many molecules. So if there is a 2H2, it means I have a H2, and then I have another H2, and each H2 has two H atoms. I'm just going to write it here. So 2H2 mean you have H2 and then H2. So you have a total of 4 H atoms. Okay. And then if there isn't a coefficient at the front, that is the same as having a coefficient of 1. So you just have 1 O2, which is 2 oxygen atoms. And then going to the products, I have 2 H2O, which means I have a H2O, and then I have another H2O, which means you have a total of 4 H atoms, 2 from each H2O, and you have a total of 2 oxygen atoms, 1 from each H2O. So that's how you interpret the coefficient as well as the subscript in a chemical equation. Understanding the symbol, so G is gas and L is liquid. So in this case, you have two gases combined together to produce a liquid, which sometimes happens. Okay, let's do all three dot points using another example. So once again, the reactants are on the left side of the arrow, and the arrow is pointing towards the product. So reactants are here. Magnesium and hydrochloric acid would be the reactants, and the products are here. Okay, so you have Mg with no coefficient at the front, which is the same as 1 coefficient. So it just means that you have one Mg atom, and then you have 2 HCl, means that you have 2 H atoms and 2 Cl atoms. So that's everything that you have on the reactant side. Going to the product side, again, there is no coefficient here, so it means as MgCl2, you have one of it, so you have one Mg, and because there's a subscript here, you have 2 Cl atoms. And lastly, H2, so one H2, so you have just one H2, which is the same as 2 H atoms. So because this equation is already balanced, you should have the same number of atoms for every element. Sorry, each element will have the same number of atoms on the reactant side and the product side. I'm not trying to say that you have the same number of magnesium as you would hydrogen and chlorine. Okay, so symbols, this is a solid, so magnesium is a solid, H2 is a gas, and the last symbols that we haven't seen is AQ, and AQ just means dissolved in water. So for example, if I have some table salt and I put it in a cup of water and I store it, that is called an aqueous solution because it's dissolved in water. So water is not shown, but the substance is in a solution with water. All right, and last but not least is an ability to balance chemical equations. And I actually thought a lot about this when I was teaching this for the first time because I don't really like the method that you were taught in junior years when you list every single element out and then you just do a balance game, and you can do that, but I feel like I was trying to think about what I actually do when I balance chemical equations, and I think the only difference between someone who start balancing chemical equations and someone who have balanced chemical equations for a while is whether or not you can think of an entire molecule as a whole rather than just focusing on discrete elements. I'm going to show you what I mean. So let's say, for example, you need to balance this chemical equation, which is magnesium hydrochloric acid. This is the equation we just saw earlier. So the way that I would approach balancing it, and it may sound like it's a very complicated process, but essentially once you get very good, you will do all of this in your head and just write the answer. But what I want to do, what I normally do when I look at this is the first thing is I try to represent the substance using the diagrams in my head, or if you're not sure, you can draw it out. So magnesium just means that you have one magnesium atom like that. So HCl, when you have two elements next to each other, it means that they will combine like this. So I'm just gonna have the two circles overlap just to show that HCl is like one discrete unit. And this is something that I think it's evidence of students with very good chemistry understanding is they understand the concept of molecules and compounds when atoms are combined together in a way that you cannot just break the combination, and you cannot just have H and Cl separate from each other. Okay, and then you have the product. Now, once again, this is H2, so there are two H atoms in this molecule, so I'm just going to draw them together, and I'm just going to overlap the circles just to indicate that the two H atoms have to be together. You cannot separate one H atom from another H atom. And lastly, we're looking at MgCl2. So there's one magnesium atom here, and there are two chlorine atoms. You don't have to draw them in this orientation, but once again, the idea is whether or not you understand that the magnesium and the two chlorine atoms have to stick together. All right, so that's step one. And once you've done this, essentially you're going to balance by just adding more of the entire thing. So let's think about this. So magnesium is already balanced. There's one here, and then there's one here. Chlorine is not balanced. You have one chlorine on this side and you have two on this side, and hydrogen is not balanced. You have one on this side and two on this side. So I'm going to, if I add one more of this whole thing, if I add one more HCl, I would be able to balance hydrogen and chlorine. So everything is going to be balanced. So that's it. So you add one extra HCl, and then once you've done that, you could then count how many of each substance you need and then balance your equation. So I just need 1 mg. You don't have to write one here, but yeah, I'm going to do it. Essentially, there's a 1 there. You have 2 HCl, 1 H2, and 1 MgCl2. So that is the balance equation. Or you can write, okay, you can write just Mg plus 2 HCl going to H2 and MgCl2. Okay, so that's the first example. I'm going to do one more. So this question is from page 86 of the Core Science booklet. I think I've set it as homework and a lot of you have done it. So once again, step one, I'm just going to draw little diagrams to show how the atoms are connected together in a molecule. So P is just one of this thing. O2 means you have two oxygen atoms connected together, and P2O5 means you have two phosphorus atoms and 5 oxygen atoms connected together. So this is what each substance will look like. All right. And then I'm going to try to balance. So let's look at P. P is not balanced yet. You have one here and you have two on this side. So I'm just going to add one more P, which is good. So this P is now accounted for. But the oxygen is not balanced. So you have one oxygen, two oxygen. So you need more because you have 3 more oxygens on the product side that is not on the reactant side. So let's say if I add one more O2 on this side, you cannot add 3 oxygen on the reactant side because every time you add, you have to add an entire molecule. So you can only add the oxygen in pairs in this case. So these oxygens are now accounted for, these oxygens are accounted for, but I still have one oxygen that is not balanced. So let's say, okay, I'm adding another one of these. Now, we have an issue now because now that every atoms on the product side has appeared on the reactant side, you have one extra oxygen on the reactant side that is not accounted for. The only way to fix this is to add more things on the product side. But because this is the product, if you want to add more things on the product side, you have to add an entire thing. And there's just really no other way to get around it. So, okay, so this oxygen is now balanced, but I have a few more phosphorus and a few more oxygen. However, I don't think this is too hard to solve. If I just add 4 more oxygen, everything will be accounted for. So that's that, and then there's this. And then if I add 2 more P, everything on the left will be on the right. So now the equation is balanced. And then you can add the, I think I have it here. Yep, so you have 4 of the P, you have 5, 1, 2, 3, 4, 5, the O2, and 2 of the P2O5, and your equation is balanced. Okay, so that's the second example. Once you get very good, you don't have to draw anything at all. You can just draw all that in your head. But if you're stuck, this is one way to sort of scaffold the question a little bit more for yourself. Next example, sometimes you can tell. So SO3, H2O, H2SO4. So S, there's one S on each side. O, 1, 2, 3, 4, and H. So this equation is actually already balanced, which means that you just need one of each for a balanced equation, and that's fine. Okay, last example, O3 to O2. So O3, 3 oxygen atoms connected together, to O2, 2 oxygen atoms connected together. Okay, so this one's accounted for, this one's accounted for, but I need more oxygen on the product side to equal the reactant side. Let's say I do one more here. So this one's accounted for, but now I need more oxygen on this side. So let's do one more here. And now I need more oxygen on the product side. So let's do one more here. Okay, so now every atom on the reactant side has appeared on the product side. So I need 2 O3 to 3 O2, essentially. I think I have one more example for you. Okay, this one. So start with N2, 2 nitrogen atoms connected together. O2, 2 oxygen atoms connected together, and NO2, 1 nitrogen and 2 oxygen. So the nitrogen is not balanced, so I'm going to add more. So now the nitrogen is balanced, but once the nitrogen is balanced, the oxygen is not balanced. So I need to add one more oxygen, and I think that will solve that problem. Okay, so you need, okay, do I have anything here? Yep, 2 and O2 and 2, and that's a 1. You don't have to write it, if you want to, it's a 1. Is that it? Yep, that's it. So that's balancing equations. There are so many more examples in this booklet that you can practice. So I'm just going to show you a few there.